Hey guys, Miss Nguyen here with our surface area of rectangular prisms notes. Alright, let's go ahead and get right to it. So we just finished our volume unit, which deals with the inside of things. So how much soda fits into a cylindrical soda can, or how much air is inside of this spherical soccer ball, or whatever, right? So the volume deals with the inside of a shape. Surface area, as you can kind of guess from the name and the fact that it has the word surface in it, that surface, we're dealing with the outside of an object. Okay, so let's start with what is surface area, like literally speaking, right? Surface area is the total covering on the surfaces of a 3D object. Right? So this is dealing with the outside of something, how much space makes up the outside of an object. So if you take 4 blocks of wood together, stick them together to make a box, right? It's the surface of that box, not what goes on the inside. So some examples of when we'd need to find surface area in real life are like when you're painting walls, wrapping presents, or measuring the surface of furniture. And maybe you have other ideas too, but those are some 3 really common times you would need surface area. Okay, so now let's go ahead and talk about the parts of a rectangular prism, because we're going to cover rectangular prisms first when it comes to surface area. Okay, so the bases are the 2 parallel and congruent. So congruent, remember that means equal or same. It's an important word. 2 parallel and congruent faces on the top and bottom. So whenever we're dealing with these problems, our bases are always going to be on the top and on the bottom. Think of them as like a lid, the 2 lids on something. The lateral faces, it's the next part, those are the 4 rectangular faces that wrap around the bases. And you'll see here in a little bit what I mean by that. Okay, if you don't fully understand, but it's basically, well, you'll see here in a little bit. The last one is the height. Okay, this is just like in volume. The height is the distance between the 2 bases. It's also a connecting line between those 2 bases, and you'll see what I mean here in a second. Okay, so maybe this shape might be familiar to you, this thing here, because if you've done surface area previously, like last year, it might have been using one of these, which we call a net. So this kind of shape, this is called a net, okay? And there's different parts, but when you fold these all together, fold it up, it creates a rectangular prism, right? I'm going to show you guys what the different parts of the rectangular prism look like when it's part of this net. And I'm going to color code each of those. You can feel free to use different colors if you want to. This is just my way. Okay, so first we have the bases. So those are the 2 parallel and congruent faces on the top and bottom. So you can see that these 2 are very different from the other 4, right? So these are our 2 bases. Next type, these are the lateral faces. Okay, so there's 4 of these. Right, so there's our 4 lateral faces, and if you were to fold this up, these 4 rectangles would wrap around the 2 smaller ones. So that's why we call these the lateral faces, because there are 4 of them and they wrap around the top and the bottom. If you were to cut this out and fold this up, that's how it would go. You would fold the top 2 in like little tabs, and then you would take the other 4, kind of fold it, wrap them around. So these are on like the, I don't know, the outside, the sides, right? So these are the lateral faces. Finally, we have the height, which I'm going to do in yellow. So the height, remember, connects the two bases together. It's the distance between the two bases. So in this net, this is the height right here. Or it could also be this. If you find a line that connects the two bases together, that right there is the height. Okay? Alright. So using those same colors, let's practice finding the parts of a rectangular prism now in 3D. Okay, so we got this. So I'll do the first one with you guys. Bases are always on the top and bottom. So here's the top. Here's the bottom. So the height connects those two together. So here's the line that connects the two bases together. So that means that this line is the height. The height is not part of the base. You see how you have this rectangle here? It's all one part. The height is separate. It's part of a different rectangle. Okay, so I want you to do the same thing for the next three. Remember, the bases are always on the top and the bottom. Then if you find the line that connects those two bases together, that line is the height. Okay, so pause this video. Take a second to do that on your own. Okay. Let's move on to this table here, okay? And we're going to look at the formulas, because before when you did surface area, basically you used this net, right? So you found the area of each of these rectangles and then you added them all together. Well, now instead of doing that, we have a little formula we're going to use instead. Okay, well, there's two different types of surface area. We have lateral and we have total. Lateral surface area does not include the bases. Okay, so that is just the outside, like a little sleeve. Let me show you. Fold up a little post-it note and show you. Okay. So this is an example of when you would find lateral surface area. See how this makes a little box, but it doesn't have a top or a bottom? This outside covering, this is the lateral surface area of this little rectangular prism because there's no bases. There's no top and there's no bottom, so we're only dealing with the four sides, right? Lateral surface area does not include the bases. Total surface area includes the bases. I wonder if I can rip up this other. Okay. So here is our rectangular prism. And I just folded this little post-it note so you can see, like, well, this is extremely messy, but hopefully you get the idea. Now this makes total, because now this rectangular prism also has bases, right? So that's the difference between lateral and total. So lateral has a much simpler formula because you don't have to worry about the bases. The total formula looks like lateral. It still has the same pH, but then it adds this part as well. Okay. So let's look at the lateral formula first. It says lateral surface area, LSA, equals P times H, right? The P, you might be able to guess, this is perimeter. This is perimeter of the base. Perimeter of the base. H, as you can probably guess, stands for height, but this is height of the prism. Okay? So the steps you want to take. Step 1, find perimeter, which is P, by adding up the four sides of the base. Step 2, multiply the perimeter times the height of the prism. Easy peasy, 2 steps. So find perimeter, multiply the perimeter times the height, that gives you the lateral surface area. Done. Total surface area is a little bit more involved. These first two are the same. I'm just going to copy paste. Perimeter of the base, height of the prism. That part is the same. Then, for that last one, we have a capital B. Hey, this is exactly the same as volume. This is area of the base. Area of the base. Okay. Well, if you look at a rectangular prism, the base right here is a rectangle, right? So area of the base is telling us to find the area of a rectangle, which you do that by doing length times width. Which we can just say L times W. Okay, that's pretty important. So this one is a little different. Step 1 is the same. So I'm going to copy paste this part. We're going to find perimeter. I will copy paste all of it anyway. Find perimeter by adding up the 4 sides of the base. This part is different. Okay. Find area of the base. By multiplying the length of the base. Oh, I forgot to label this. Length of the base times the width. Finally, step 3, plug P, B, and H into the formula. So you're going to find all these letters that you're missing and then plug them into the formula and solve. Okay? So let's take a look at an actual problem. Okay, let's start with lateral surface area. Let's find the lateral surface area of the prism below. Start as usual, shade the bases. So when we shade the bases, we can see what the connecting line is, and that connecting line, here's the connecting line that puts these two bases together, and that is the height. Okay? So, now we've got that, we can start our problem. So our problem, it's lateral surface area, so LSA equals PH, perimeter times height. Okay? Well, a strategy we can use to make this a little bit easier is if we redraw the base, okay, because this is in red, same, so here's our base, here's 5 and 5. Since this is 5 and 5, these two sides opposite them need to also be 5 and 5, so hey, this is a square. This helps you to really see that these are the numbers that you use for perimeter and for area of the base. That height, that 8 centimeters, is not part of this rectangle. So we're going to ignore it. We only use it once here in the formula right here. Aside from that, H should not be anywhere. So to find perimeter, we're adding up all the sides. There should be 4 because it's a rectangle. So that is 5 plus 5 plus 5 plus 5, which is 20. H, we already said, is 8. We see that from the picture. So LSA is the perimeter times height. The perimeter is 20. The height is 8. So we multiply those two together. 20 times 8. We get 160. It's in centimeters. Because it's surface area, it's centimeters squared. That's it for lateral surface area. It's pretty easy peasy. Number 2 is total surface area. Same process, one more step. Base, base. Let's find the line that connects the two bases together. So this is it right here. So this is the height. Formula for total surface area is TSA equals PH plus 2B. This 2 was very important. So after you find B, you're going to have to multiply it by 2. Don't skip that step. Let's redraw the base. I'm going to use the rectangle tool so it looks a little bit neater. Here you go. Here's our base. 11, 4, 11, 4. So step by step, perimeter is 4 plus 11 plus 4 plus 11. 4 plus 4 is 8. 11 plus 11 is 22. 22 plus 8 is 30. The height, we already labeled the height, is 3 inches. So the last letter we don't know what it is B. Remember, B is area of the base. So that is length times width. So length times width is back of the base, right? So if you look at the base, so we're looking at this picture now, ignore the 3D one. This is the length, it's long, right? And this is the width. So area of the base is 11 times 4, which is 44. So this now gives us our 3 numbers. So TSA equals PH plus 2B. P is 30. H is 3. Plus 2 times B, which is 44. So this here, 30 times 3 plus 2 times 44, is what we can go ahead and plug into Desmos. 30 times 3 plus 2 times 44. That gives us our answer of 178. The units are in inches, so this is inches squared. Okay, so see, there's not a huge difference between lateral surface area and total surface area. It's just really one more step, that's all. Okay, now let's look at number 3. We are going to find the lateral and total surface area of this prism below. So same prism, and we're going to do both lateral and total. Same steps. Shade. Here's our bases, which means that this right here, this connecting line that connects the 2 bases together, is 14. So our height is 14. Let's redraw our base. This is 6 by 13, so this is also 13, and this is 6. Now we've got what we need, we can start. Let's do lateral surface area first. Lateral surface area is PH. Perimeter, we're going to add together these sides. 6 plus 13 plus 6 plus 13. 13 plus 13 is 26. 6 plus 6 is 12. 26 plus 12 is 38. The height we have already labeled as 14. So lateral surface area is just perimeter times height. It's 38. Oops, colors. 38 times 14. It's 532. Okay, so that's our lateral surface area. 532 square millimeters. Okay, so now let's do total. I have more space now. I'm going to move this up a little. Nice thing is we just found pH, because lateral surface area is pH, so that means this 532 can go right there. So the only extra thing we need to find is B, which is length times width of our base, so that's going to be 13 times 6, which is 78. So then we can just plug all of these numbers into our TSA formula. TSA equals pH. We already did pH. That's 532. pH plus 2 times B, which is 78. So this is 532 plus 2 times 78. Okay, that gives us our answer of 688 millimeters squared. Not too bad, right? Okay, These last two are independent practice, but I do want to walk you through them a little bit just so you can understand the reasoning. Okay. Number 4 says, Adam is going to close and wrap the box shown in wrapping paper. How many square inches of wrapping paper will he need? Okay, when you wrap a present, are you wrapping the whole present or only the sides of the present? Okay, yeah, you wrap the whole present, so that means this is total surface area, because we're wrapping the whole side. So don't need to find lateral, total only. So that's the formula. TSA equals PH plus 2B. I can help you guys out a little bit. Let's redraw the base. It's our base. Right? It's hard to see on this kind of 3D shape, so you might have to sort of draw in the... Looks really sad. Something like that, right? Those are our bases. It's 2.5 by 2.5. So it's a square on the bottom. Okay? So you should be able to solve the rest of number 4 on your own. I did help you get started. So remember, when you're finding perimeter and area of the base, you're using this picture right here. The only time you need the height, the only time you need this height is right here. It should not go anywhere under P or B. Okay? That's important. Number 6 says, Gloria's room is shaped like the prism shown. If she wants to paint the walls of her room, not including the ceiling, how many square feet will she be painting? Right? Well, just think about logically. Look around you. If you're painting the walls, you're not painting the top or the bottom, so that is lateral surface area. So the lateral surface area equation is just pH. Let's redraw the base together. Here's the bases, so this looks like 12 by 9. So you can use that to find the perimeter. So remember, you're just adding together the 4 sides of the base to get the perimeter. Then you multiply that by the height. Right, here's the height connects the 2 bases together. Once you do that, you're home free. Alright, that's really all there is to rectangular prism surface area. So I hope this video was useful for you and that you're ready to tackle this and triangular prism soon. See you in class.